After we're done drawing a Lewis structure, we always want to check to see how good our drawing is or how valid it is. We assign something called a formal charge to every single atom inside of the Lewis structure. And this is a fake charge. It's not really the charge of that atom, but it's a way of us to keep track of how many electrons we've assigned to a particular atom inside of the Lewis structure. And our goal is to make sure that the number of assigned electrons in our picture matches the true number of valence electrons that we know that that atom contains. So we use formal charges to check how valid or how good our Lewis structure is. And it is best when all the atoms have a formal charge of 0. And the way that we're going to calculate formal charge is we take the number of valence electrons for that atom and we subtract the number of bonding lines that we drew around it. And then we subtract the number of lone electrons around that atom, or in other words, the dots. So formal charge will be equal to valence electrons minus the lines and then minus the dots around that atom. So let's take a look at some examples. Number 1 here, we have 2 Lewis structures for the same compound. I'm going to give you a moment, hit pause, record these 2 Lewis structures, please. Now you're looking at these 2 Lewis structures and you say, okay, they look good. They both look good. They both have the correct total number of electrons. Everybody has 8 valence electrons around it. We're looking good. So what's the big deal? So let's focus in here on the one on the left, and we'll just call this Lewis structure A. Okay. Let's calculate the formal charge of every single atom inside of Lewis structure A. And remember, the way that we're going to do that is we're going to take the number of valence electrons, subtract the lines, subtract the dots for every single atom. So let's start here with the carbon. So carbon, I know from the periodic table, carbon has 4 valence electrons. And looking at the picture I've drawn here, we're going to subtract all the lines around the carbon. So I have 1, 2, 3, 4 lines. So we're going to do minus 4. And then count the number of dots that we have around the carbon. We call these the lone electrons. There are 0 lone electrons around the carbon. So carbon's formal charge is going to be equal to 0. Let's repeat this for the fluorine. Okay. Fluorine, I have 3 identical fluorines, so I only have to do this one time. One fluorine has 7 valence electrons. The fluorine that I have in our Lewis structure has 1 line. And then now I count the dots, 1, 2, 3, 4, 5, 6 dots. Fluorine is going to have a formal charge equal to 0. And last, let's calculate chlorine's formal charge. Chlorine has 7 valence electrons. The number of lines coming off of the chlorine is 1. And the number of dots around the chlorine is 1, 2, 3, 4, 5, 6. So chlorine has a formal charge of 0. And I'm looking at how good this Lewis structure is. First thing I notice is that everybody has a formal charge of 0. That's really good. And then another thing I need to check for, I need to make sure the sum of the formal charges equals 0. And it does. So I'm going to repeat this for our second Lewis structure, and we'll just call this Lewis structure B. I want to calculate the formal charge of all the elements again, and we'll just go carbon, fluorine, chlorine again. Carbon, I know, has 4 valence electrons. In this picture, carbon has 1 line, and 1, 2, 3, 4, 5, 6 dots. So 4 minus 1 minus 6. Carbon's going to have a formal charge of -3. Fluorine, 7 minus 1 minus 6. Again, it's identical on this side. Chlorine, 7 minus 1, 2, 3, 4, and then 0 dots. This chlorine has a formal charge of +3. So I have a +3 on the chlorine, a -3 on the carbon. I'm looking here at the formal charges, and we said earlier that formal charges of 0 means that we've used the correct number of assigned electrons for that atom. I have a -3 and a +3. That's not so good. The atoms are not so happy with having formal charges of +3 and -3. So in comparison to structure A, structure B doesn't have the optimal formal charges. Even though when I do add the sum of all those formal charges, I do get 0. Like that's good. But the fact that I have the -3 and the +3 doesn't make this an ideal Lewis structure. So between these two Lewis structures, the more valid Lewis structure is letter A. This is the better Lewis structure for this compound. So if you were to draw letter B on a test or a quiz, that would be marked wrong because there's a better Lewis structure that we can draw. Let's try another one. In example number 2, we've got carbon dioxide. Hit pause, take a moment to record these two Lewis structures. Okay, in structure A, we're going to go through the same process. We're going to assign formal charges to every single atom in our Lewis structure. And for the purposes of this example, I'm going to highlight the oxygen on the left just so we can keep track of this oxygen. All right, so the formal charge of that highlighted oxygen has 6 valence electrons. Subtract the lines, 1, 2, and subtract the dots, 1, 2, 3, 4. This oxygen has a formal charge of 0. Now for the carbon. Carbon has 4 valence electrons. Subtract the lines around the carbon, it's 4, and 0 dots. So carbon has a formal charge of 0. Now for the last oxygen that I will not highlight, 6 minus 2 minus 4, get a formal charge of 0. The sum is 0, so that's a check. Okay. The sum of the formal charges must be equal to the charge of the molecule. In this case, we have a neutral molecule, so it has to be equal to 0. And then I check the formal charges for each element or each atom in the Lewis structure. I got all zeros. That's looking pretty good. Well, let's take a look here at Lewis structure B. We're going to do the same thing. I'm going to highlight this oxygen here on the left. So the oxygen on the left is going to have a valence electrons of 6 minus 1, 2, 3 lines minus 2 dots. So this oxygen on the left, 6 minus 3 minus 2, we get a positive 1. Now for the carbon, 4 minus 4 minus 0 is a formal charge of 0. That's good. And then our last oxygen, 6 minus 1 minus 1, 2, 3, 4, 5, 6. This has a formal charge of -1. So here are our formal charges in our Lewis structure. I got a +1 and a -1 and a 0. Yes, together that adds up to 0, so that's looking good. However, this formal charge of +1 and -1, remember we're going for zeros. We rather have formal charges of zeros as we do here in structure A. So structure A is the better or the more valid structure. So we would want to draw structure A rather than structure B, because in structure A, all the atoms have a formal charge of 0, meaning that we've assigned the correct number of electrons to every single atom. Example number 3. Here we have the polyatomic ion nitrite. 2 oxygens. Overall charge -1. Please hit pause. Record these 2 Lewis structures. Okay, so again we'll have structure A and structure B. Let's compare the validity of these 2 Lewis structures using formal charge. So again, I'm going to highlight this oxygen here on the left for both of these. Okay, so our highlighted oxygen in letter A, 6 valence minus 1 line minus 6 dots, I get a formal charge of -1. Nitrogen's turn, 5 valence minus 3 lines minus 2 dots, 0. Last oxygen there, 6 minus 2 minus 4, I get 0. Okay, so first of all, the sum of the formal charges has to equal the charge of the entire molecule. So add up all these formal charges, we get -1. This is valid because our charge is a -1. Okay, this is a polyatomic ion, so I have to make sure the sum of those formal charges equals the overall charge. And when you have to have an atom with a negative formal charge, we want to make sure that it's the more electronegative atom. Oxygen has the negative formal charge in structure A, and yes, oxygen is more electronegative than nitrogen, so this is okay for right now. But let's check structure B and see if we have something better. So our highlighted oxygen in green, we have 6 minus 2 lines minus 4 dots, 0 formal charge. Nitrogen is also 0. And this remaining oxygen is -1. So first thing to check for, do the sum of the formal charges equal the overall charge? Yes, we're good. Something had to have a negative formal charge, and that is the oxygen. That is the most electronegative element here, so this is okay too. So I'm looking at these 2 Lewis structures, and I see here that they both add up to -1, and I have the -1 formal charge on the more electronegative atom. These 2 Lewis structures are equally valid. Both of these are right. Okay. This is a case where we have something called resonance. We have 2 equally valid Lewis structures. So when we have 2 equally valid Lewis structures, I'm going to draw a double arrow between these 2 Lewis structures, saying that both are right. Okay, that double bond could be found between the highlighted oxygen and the nitrogen or the unhighlighted oxygen and the nitrogen. It doesn't matter. So in summary, formal charge, there are these fake charges that we assign to each atom. Okay? It's valence electrons, minus lines, minus dots. We're aiming for, we want formal charges equal to 0. That is the best. Some ground rules though. The sum of all formal charges, and we'll just say FC, sum of all the formal charges of the atoms has to equal the charge, okay, of the molecule. So if you have a neutral molecule, has to be equal to 0. And if you have an ion, a polyatomic ion, it has to be equal to the charge of that polyatomic ion. And if we have to put negative formal charges, the more electronegative atom gets the negative formal charge. So if negative formal charges are necessary, they're unavoidable. We try to avoid them at all costs, but if they're unavoidable because we have a polyatomic ion, that's a negative charge, then we want to make sure that the formal charge goes with the more electronegative atom. And then if we have two or more equally valid Lewis structures, we have what we call resonance. So resonance, you're going to use the double arrow between your Lewis structures. And this means you have equally valid Lewis structures.